Hello everyone, and welcome to part 3 of these chapter 6 videos where we are continuing the idea of percents. But in this case we're going to start dealing with a little bit more like word problems, kind of applications of this one. And in particular our applications are having to do with percent change. And so one of the huge things that we want to deal with percent is percent change, where you have either a percent increase or a percent decrease. And we have kind of an overarching formula for this one, that a percent change, it's given by the amount of the change, the actual amount, numerically, just the literal amount. So if something goes from 4 to 5, it changed by 1. So that would be the amount of the change. And then we want to divide by, basically here, whatever was the original amount. Because if something changes, it's changing from something to something else. And the original amount where it came from will go onto the bottom here. And this will give us, of course, when we do this kind of a division, it's going to give us a decimal. And so we would have to convert the decimal to a percent in order to get the percent change. But let's see how that works for this one. A number is decreasing from 88 to 77. So it's going from 88 to the number 77. Which means the original amount is 88 and then it's becoming 77. And so the percent change over here, and you notice we don't have to worry about necessarily if it's increase or decrease with this one. The amount of the change, it should always just be some positive amount. And so the way that you end up doing it is you either could take absolute value of the difference, like absolute value of the new amount minus the original amount, something like that. Or you could just make it more simple, and here of course going by the original. You can make it more simple by just doing the subtraction in whichever order you need, always subtracting like the smaller number from the bigger number. So we would go on top like 88 minus 77. And the original number, it was originally 88, so we'd go divide by 88. And then let's see what we will get for that one. We're going 88 minus 77. Which of course is 11, and then when we go divided by 88, it will go 0.125. And so this one as a percent, of course we need to move the decimal 2 places to the right. It would land between the 12 and the 5, so it goes 12.5% decrease. Now what about this one? We're about to see here a really nice way that you can either increase or decrease a number by a percent. And so I will write the general kind of a formula here. To change the number y by x%, we should go y times 1 plus here or minus. And what I'm going to say, the plus is if you're increasing, and the minus over here is if you're decreasing. So if you want to increase something by a percent, you go 1 plus. If you're decreasing by a percent, you would go 1 minus this thing, which is you just do the percent. Of course, so when you want to do minus a percent, like 1 minus a percent, this should be a decimal. So another way to think of that one is take 1 plus or minus, depending on increase or decrease, x out of 100. That would give you as a decimal. So if it's 50%, we don't do 1 plus 50 and get 51. We should do 1 plus 50 out of 100, which is like 0.5. It becomes 1.5. So I hope that makes sense. We're about to see an example for it here. We want to increase 950 by 40%. And so the reason for all of this formula and everything is because essentially, we want to increase by 40% of 950. So we don't want to just increase by 40%, which is the number 0.4. We don't want to add 0.4 to this one. We want to add 40% of this number, 950. And the way we do that is by taking 950 and multiply times 1 plus 40%, because we're increasing, so it should go plus. And 1 plus 40%, 40% as a decimal goes 0.4. And so it goes 1 plus 0.4 is 1.4, of course. So 1.4, doing 950 times 1.4. And what do we get for this one? It goes 1,330. Now we have some kind of an interesting question here, and sometimes for these percents, I think that it's helpful to make a little bit of an equation. Of course, in the last chapter we were practicing using equations to solve business problems, and so we don't want to just completely forsake everything that we learned about making equations. Why don't we use it to our advantage here, where it says sales at the LL Boutique decreased by 10% this month compared to last month. So the last month's sales decreased by 10%, and that gives us the sales now. It says the sales this month were this amount, so what were the sales last month? Well, let's think again about what it was talking about. The sales decreased by 10% this month compared to last month. So from last month, we should have basically a decrease by 10% to get this month. And we just talked about how you would decrease a number by 10%. So if the last month, why don't we call last month is going to be capital L. This month can be capital T, like for this. Last month decreased by 10% will give us this month. And so to decrease last month by 10%, we should multiply times 1 minus this time 10%. That will give us this month. And here we could actually do this subtraction because 10% is the same thing as 0.1. And so 1 minus 0.1 should be 0.9. And so here we would get this kind of a thing. 0.9 times of L is T. 0.9 times of last month will give us this month. And then it tells us what the sales are this month. It says they are 121,581. So that should be this month's sales. So it goes 0.9 of last month's sales are 121,581. And then we're trying to solve for L, of course, is being multiplied times 0.9. So we just want to divide on both sides, divided by 0.9. And so what will we get? We're trying to do that number 1,100, I keep saying 1,000, 121,581 divided by 0.9. And that should give it to us. You know, in the book, they try to give us so many different kinds of formulas, but really it comes down all to the same formula about increasing or decreasing by a percent, or the formula about portion, rate, and base being related to each other. If we can keep those two formulas in mind, or those two relationships in mind, then we would be able to solve every problem without this multitude of formulas. And so here, last month it was $135,090. If we decrease this number by 10%, we will end up with this month's sales. You can check that one. And now we have, for number 20, kind of a weird question where it's talking about percentage points. Now, percentage points, they're being used, it's almost taking percents, it's like meta percents, if you know what I'm talking about, how we have percents of percents. How does it work? So here, shareholders, they're being informed that the company's market share increased from 6.5% to 9.1%. So we're trying to figure out what was the increase, the percent increase to go from 6.5 to 9.1. Here, the fact that it goes percent doesn't really matter. What we're dealing with is we're trying to find out what is the percent change if you go from 6.5 to 9.1. What is the percent change there? And that will be what we're looking for. So it's kind of incidental that it goes percent. Really, percent here is almost being used like a unit, you know, like dollars, like $6.50 to $9.10 or something. It's not really being accounted the way that we're using percents before. And so this kind of a problem, it's a little bit goofy seeming, but it comes up whenever you're dealing with percent. So market share or else percentage of votes or something like that. So really, what percent increase does this represent? Well, it already tells us the amount of the change. Here, obviously, it changed, it increased. We have a percent increase going from one number to another. It already tells us the amount. And so the percent increase, it's going to be the amount of the increase, which was 2.6, because of course that's the difference between 9.1 and 6.5, it's 2.6. Then we divide by the original amount, which is 6.5. And so what do we get for that one? 2.6 divided by 6.5. We would get 0.4. So 0.4 Here, of course, we want to write it as a percent, so instead of decimal, 0.4 is 40%. So that's how these ones will go. And that does it for these kinds of percent problems. I hope this video was helpful, and I will catch you guys in the next one.